Thank you, Dermot, and welcome everybody. Thank you so much for coming this evening. When I was asked to do this talk, it was meant to be one talk, but the more I spoke to John and Dermot about all the different aspects of watchmaking, there is a conflict between what I wanted to talk about, the making of watches, and what they were very interested in, how watches work. So we ended up deciding to make two talks out of it. And in truth, it's such a broad subject that you could go on and on and on. There are volumes of books written about single aspects of watchmaking. It's a 500-year history, so it's extremely vast, and I'll do my best to get through as much of it as possible over two talks. So, so here we go. I'm classed as an independent watchmaker. I do make watches, and I'm an independent watchmaker as distinct from the established brands who would have departments where each part of the watch, you're just specialists in each department specializing on a specific area of the watch. I endeavor to do everything. And now I do use some outside suppliers and work with some people in areas where it wouldn't necessarily be my strength, like for instance in case making. But as much as possible, I design and make as much of the watches as possible. And I do use some outside components, and but the important thing I think is that I employ a lot of the processes that are used to make every single part of the watch. And I think that probably is the best definition of an independent watchmaker. I was trained in the Irish Swiss Institute of Horology, which unfortunately closed in 2004. It is a great loss. I'll talk about it more later, but it was a fabulous foundation to go out into the world of watchmaking. The teachers there were extraordinary guys, and they really taught us extremely well, gave us really good skills over the 3-year course, but also they gave us an appreciation of quality and a pride in working well. And I think everybody who emerged from that college is very proud of where they came from, and they've tried to live up to the standards that are set in the college. I wanted to, I suppose watchmaking became almost like an obsession for me, because when I wasn't working or in college, I was buying books, looking for tools, and I think it's the case for very many watchmakers that you really get drawn into it. And the desire to learn as much as possible brought me to Switzerland. And I lived there for 7 years. I was very lucky to start with Audemars Piguet in the Vallée de Joux. I should be clicking through images here at this point. This is Audemars Piguet. They're considered to be one of the top 3 grand houses in watchmaking. The other two being Patek Philippe and Vacheron Constantin. There are a lot of other brands now, but these 3 brands have long histories making the very highest level of watch. And they all 3 do to this day. The Vallée de Joux is, it's just postcard pretty. It's the base of the valley is about the height of Carrauntoohil. Watchmaking traditionally started there. Well, I don't have dates, but about 200 years ago, when farmers who couldn't farm in the winter, they started watchmaking in, off season. And in the spring, they come down with their wares. The valley was literally cut off in the winter. You have 1,400 meter passes to get out of the valley from any direction. So you see farmhouses with telltale windows in the north-facing gable end. If you see that, you know that there was a watch workshop of some description up there. The idea of them being north-facing, if there are any I know there are some watchmakers in the room. One of the worst things is having direct sunlight going across your bench. You can't work like that. So having north-facing diffused light is ideal. And up in the attic, you're getting the best light in the house. So now, normally when you're looking across a industrial zone, it's not very pretty, but we literally are looking across an industrial zone in this photograph. You've got companies like Audemars Piguet, Jaeger-LeCoultre. They're the big companies that are from there, based there. But also you have houses like Vacheron Constantin, Patek Philippe, the Geneva-based houses. They also have workshops up there, tapping into the skills that exist there. I was drawn to Audemars Piguet. They're very famous for their Royal Oak wristwatch. I was drawn there because of their complications. They made more than anybody at the time when I was leaving college. And I thought I was interested in working on perpetual calendars, on tourbillons, and miniature Peters. And I fancied that my best chance of working on those type of mechanisms was working in a company that made a lot of them, rather than a company that made a very few that watchmakers would be striving to get into that workshop. I made a good choice because I did eventually get to work on those watches. At the time as well, Audemars Piguet were in the Guinness Book of Records for selling the most expensive watch in the world, which is the Grand Complication pocket watch. One a year was made. There were simpler times. Watches have gotten a lot more expensive, and the number of watches that far exceed that in price it's actually difficult to get my head around, but it was a good move at the time. After 5 years, I got the itch to really get into the development of watches. So I left Audemars Piguet and I found a company in Le Locle, which is also in the French-speaking Jura Mountains. And Christophe Clary, they specialized in developing movements for the bigger houses. At the time, he didn't sell watches under his own brand. He does now. But immediately I was working on miniature Peters, tourbillons, Grand Complication wristwatches, and the development of those watches. It was an extraordinary experience. I spent 2 years there, and I think it was exhausting, but I filled so much experience into that time. And in 1999, I decided to move back to Ireland. At the time, there was so much work for these companies. I was pushing an open door when I negotiated to get that work back here in Ireland. So ever since I returned to Ireland, I continued to make those watches, miniature Peters, tourbillons, Westminster chime and miniature Peters. So it was just very, very fortunate timing. Two of my brothers, Stephen and Anthony, they are also watchmakers. They also attended the Irish Swiss Institute of Horology. And in myself and Stephen, we developed our own brand, McGonigal Watches. I've sent, hang on, sorry, this is Christophe Clary in Le Locle, the Christophe Clary company. And this is our first model, McGonigal Watches. I've since left McGonigal Watches, and it's now run by Stephen, and he's making some extraordinary watches. He currently makes a miniature Peter that is absolutely wonderful. It's one of the finest, I think, on the market. He has another brand as well, which I've missed the slide. Yeah, he's another brand, McGon Watches. It's a more accessible price, but it's another wonderful brand that he has developed. I developed my own brand, Ilon Watches, and this is the model I currently make. It's the HB1. It's I'll talk about it later on towards the end after I show some of the techniques I use to make the watch. Okay. So with this talk, I wanted to talk about how watches were originally developed and some of the techniques they used to make them, how they transformed into precision instruments, how eventually they were industrialized, and how modern techniques, modern technology, and modern materials have since been applied to how they're made currently. So with the introduction of watchmaking, the first watches appeared about in the 16th century, and you wouldn't really recognize them as watches that look like small table clocks, but they were watches in the sense that they were portable, and they were made possible by the invention of the mainspring. And they were barrel shaped, and you can see an example there. The movements were originally made out of iron, so they used the top specialists in ironwork at the time, blacksmiths and locksmiths, and they were extremely crude, not surprisingly, because they didn't have technology to make anything finer than that. These were the very pinnacle of their technology at the time. The components were all hand cut, even the gears in the wheels. So you can imagine transmission of power was very, very variable. Springs, they would have a short range. They would have a lot of power at the very beginning and very, very little towards the end. And I think timekeeping was more notional almost than practical. But they were sought after by wealthy people. There were symbols of prestige, and they advanced in the 17th century to more ornate watches. You can see the introduction of brass over iron. They start to understand that you'd have much greater wear qualities if you had gears made out of brass meshing with pinions made out of steel. And they also started to develop more sophisticated equipment to make the watches. So they would use more indexing tools to get more even cuts on the wheels. They would use jigs that would, so with a jig, you're holding a very, very small component, and you're using a large tool to work on a very small component. And so the jig will guide the tool that you're using, and it'll give a more precise and better finish, all of which contributes to lower friction. And the result is better power transmission, better timekeeping, longer running. Then in the 18th century, watches became more precision pieces, precision instruments. Obviously, you still had the watches that were ornate and made for very, very wealthy people. But there was a great need to solve what was probably the technical challenge of the day, and it was the calculation of longitude in navigation. Latitude in navigation is relatively easy to calculate. You measure the height of the sun at midday, and you can relate it to a set of tables for the time of year, and you can tell on what latitude you are on the planet. But longitude is a lot more complicated because the sun, which is the basis by which you measure your position, is traveling across the sky, and it was a puzzler. The only way they could actually determine their position was through dead reckoning. and that was always very approximate, and it could be thrown, your calculations could be thrown out very, very easily. And once they were, you could not reestablish your position. So the solution was thought to have been worked out by astronomers, that they would find some way of relating celestial observations to where you were and calculating your position. Incredibly complicated solutions were devised. Some of them worked, but they weren't really applicable from standing on the deck of a moving ship. The solution ended up coming from the invention of a clock with such precision that you could work out your current position at midday and relate it to the clock that you have on board that is giving the time of your home port. And by calculating the difference between the two, you can eventually, through very complicated calculations, work out your position, but it could be done. And this was a game changer. It was any country that could work out how to calculate longitude precisely they could rule the waves. They'd gain commercially, they'd gain militarily, they'd expand their empire. And so various countries offered a huge, substantial prizes for anyone who could solve this. And the man who eventually did was a carpenter turned clockmaker from Lincolnshire called John Harrison. There's a fabulous book, which was eventually turned into a film by Davis Sobel, which I highly recommend. It's called Longitude. And honestly, it reads like a thriller. It's a wonderful story. And you don't need to be technical to be excited by this story. I really recommend it. His watches, you can see the first one was a clock, and but the watch he eventually won his prize with was a watch. There were technical marvels. The first clock he made, unsurprisingly for a carpenter, it was made out of wood. Even the gears were made out of wood. But he displayed a great understanding of materials by using, he had lignum vitae, which is a wood that produces a natural oil. And he used these for bearings to avoid the necessity of using a lubricant for his bearings. So he used diamond for the impulse surfaces, and he also used a system of thermal compensation. Temperature is a problem with timepieces in that with variations in temperature, metals expand and contract, and it varies the timekeeping. He used a system where he used measured lengths of materials with known rates of compensation, and he'd use other metals with different rates, and he'd use them against each other to actually balance out perfectly the thermal compensation. So it was a kind of a groundbreaking moment, because for the first time in history, people were placing their trust in an instrument rather than observations in nature. They were placing their lives and their fortunes in this technology, and it was kind of a groundbreaking moment in history, in human history. Where watches started to become accessible to people was when interchangeability was developed. And to do that, you had to produce systems where you could produce parts that were so precise that they could be interchanged. You could take a component out of a drawer and just pop it in the watch and it would work. And Vacher and Constantin were one of the first companies to develop tools to do this. One of the first tools to help with it in this endeavor was the pantograph machine. And you can see here engraving machines nowadays use this principle, where you would have a template that if I can just follow the arrow here, you're using, say, the template here to follow a large pattern, and it's engraving on at a smaller scale. The scale can be set by the length of these levers and how they work together. Now, rather than a quill or a graver marking a surface, that quill could be interchanged with a machine head. And I was trying to find a machine where you could really see what is going on. And here's one from a car workshop. It's not a watch workshop, but you can see here the pattern or the template is here and the machine head is there. So you would trace around the profile of the part which is here, and the spinning machine head would machine the component at a much smaller scale on the table there. And that was one of the machines that helped to industrialize small watch components. Also, Jaeger-LeCoultre came up with extremely fine measuring instruments as well, and also to check the precision of the components once they were made was of the utmost importance as well. And with the development of these tools, that made that possible. Then in the, hang on, I'll just pause this for a sec. Towards the middle of the 19th century in America, they started to industrialize. They created the first production line to produce watches. And Henry Ford, who had watchmaker training, followed the principles that they used in the production line of watches to develop the production line in the Ford Motor Company. So with the development of steam-powered tools, the aforementioned tools such as the pantograph machine, stamping tools, all sorts of equipment like that, watches could be made in vast quantities. And by the end of the 19th century, compared to the beginning of the 19th century, the average price of a watch had dropped by up to 95%, it's calculated. So it now was accessible to nearly everyone. And that of course had important impact socially, because people could set a precise time to go to work, and everything that follows with precise timekeeping. Here we can see one of the very interesting tools for making turned components. It's an automatic lathe, and these have been superseded by CNC controlled or computer controlled lathes. But I find these really fascinating. When I first arrived in Switzerland, these were in common use in companies such as the Swatch Group. So you'd have vast rooms with hundreds of these lathes, just making tiny screws and pinions and shafts. And I knew there was a watchmaker in Denmark, Christian Lass. He makes these fabulous handmade watches, and he has taken some of these machines that have been taken out of commission, and he has restored them, and he uses them in the production of his own watches. So you can see that, the cams are actually guiding the cutters as the stock protrudes. It's fed through the collet. And so as the piece of metal, the bar of metal advances, you can see their profile of the cam, and that's the command cam. And there you can see they are screws. So it's like a little train of screws that have just been turned, and he'll part them off. He'll finish them on another machine. But so I just thought that was, it's a fascinating thing to see in motion. But it also helped in the industrialization of watches. Okay, if I just proceed. So in the 20th century, we continued very much in the same vein until the introduction of CAD. And I think that has been a massive leap forward in how watches are designed and made. And you can see here a 3D drawing of the case of my watch. And so everything is calculated to an infinitesimal level. This file can be checked. You can see that something is working. You can then use that file, send it to a CNC machine or whatever machine is going to make it. And it's made within a very, very tight tolerance. And you can also check the aesthetics of a watch. You can get very accurate renderings to see what your watch is going to look like. What we had to do when I first arrived in Switzerland was you were working off hand drawings of watches, the aesthetic drawings. You would get technical drawings, you would make it, you'd look at it and kind of go, okay, we need to change a lot of things here. And now an awful lot of that guesswork can be taken out by rotating the watch, by looking at it from different angles. You can get the cases 3D printed. You can just check the volumes. You can see how it is on the wrist and everything like that. And it's saving time, it's saving money, and it's allowing us to make much more advanced designs. And so you can just, I'll just flick through a couple of these here. Now, I didn't do these drawings myself. The man who did is in the room here, Graham Houghton. He's and you can see here we have a sapphire dial on the bottom, and the raised part of the dial are machined. It's machined brass, which is then coated and finished and printed. So it's quite a complex dial and made all more easy by CAD process. Here you can see the seconds hand on this is for, again, the HB1, the chronograph. And the reason I'm showing this is because apart from being a nice looking hand, it's also calculated to have the center of gravity as close to the center as possible. So very important on the center seconds hand, because you can get an awful wobble on a hand if it's not properly balanced. And with a chronograph, you've got quite a violent return to zero. And if it's not balanced, that can also have repercussions as well. So CAD makes this makes the designing of the hand so much easier. And there's an accurate rendering that you could almost mistake it for a photograph of the watch. So again, you can see how this is very, very helpful in determining the aesthetics of the watch before you actually make it. Here is a short video of a watch we worked on together. It has
the original inspiration for the Remontois that Derek Pratt incorporated into his Tourbillon pocket watches was taken from a small clock.
And
the idea to use his Remontois in a wristwatch came prior to Derek's passing.
You can check that something is functioning.
Functionally,
in the
Remontois regulates the power from the mainsprings, which is delivered to the escapement once every second, resulting in an extremely consistent power flow and thus better timekeeping.
You even get views from
At the center of the
it would
remotoir
be
is a
impossible for a
rouleau-shaped
watchmaker to
ruby
get
cam
under the microscope
that is
or
directly
an
connected
eyeglass,
to the escape wheel.
because you can turn it every which way. You can get rid of
As the
bridges,
cam
rid
rotates,
of your main
it is
plate,
followed by the
and you
remotoir
can
fork that moves
see
back and
exactly
forth,
what's going
releasing
on
power
from every
by
aspect.
the remotoir wheel,
So
which
it's
recharges the
incredible
remotoir
tool.
spring that is directly coupled with the escape wheel. This process repeats every fifth beat of the balance wheel. Exactly.
Okay. I just want to talk I mentioned materials earlier on, and you often hear talk about jewels in a watch, and jewels are non-precious, they're synthetic. It's synthetic sapphire with an oxide added to give the ruby color. Originally, they were either diamond or ruby in watches about in previous centuries. Nowadays, for greater accuracy, they're made in a furnace. They create a glass boule, as they call it. They slice it, they polish it, they cut it into little rondelles, pierce it either with a laser or originally with a copper wire infused with impregnated with diamond. And the jewel, well, the bearing is composed of two parts. It's the jewel material with a hole in it and the pivot on the wheel that's protruding through. And you would have another one on the other side of the bridge. So you'd have one on the main plate, one on the bridge, pivots either end. So you can appreciate, you can really accurately control the amount of play, and it's used because it's a hard material. It doesn't wear very easily. It's got good wear characteristics while working with steel. It doesn't wear the steel very badly at all. It also has good oil retention qualities and very low friction. So it's a fantastic material, and it really was a big leap forward in watchmaking as well. Other materials that they use in modern watchmaking, I don't have examples of them here. It's better that I describe them rather than show them. I suppose in the making of watches, we use a lot of, rather than using steel cutters, we use tungsten carbide a lot now. Again, it's extremely hard. It can work on harder materials, but it gives really clean cuts. It's very, very high precision. And you have industrial diamonds used as well. I can show you some a little later on. And but also we use more materials like titanium, either for the cases. Some watchmakers use them for components inside the watch. It's light, it's anti-allergic, and it's a very good material for watch cases. Synthetic sapphire, it sounds like an exotic material, but most watches sold today would have the crystals would be synthetic sapphire, so they're very scratch resistant, and it's pretty much standard on watches now. We are using silicon in, I'm going to say we, in the watch industry, they're developing a lot of components made out of silicon. Now, these are made by using processes which would be very similar to the fabrication of microchips. So it's using lithography to mask and expose to an ultraviolet light. The material is then washed away, and the resultant material that's left is about as precise as you can imagine. It's been used now for escapements, it's used for hairsprings, and they're also mixing it with other material to produce materials such as silicium, and there are other variants as well that give characteristics that give extremely high precision to the timekeeping. And so it's I think it's almost indistinguishable, the industry, from what has been made in the past. And you might be wondering how independent watchmakers fit into all of that, and I'll try and show it now in a sec. While I still have it on the screen, I have, you can see there's a jewel assembly. So you have a flat jewel there without a hole in it. You have a small jewel in a setting with a hole, and you have this brass setting and a spring on top. It's an exploded drawing. It all fits together, and it is a shock absorbing assembly. So when you see shockproof on a watch, you don't see it anymore because all watches have these systems. But this allows you to drop your watch, and for the delicate balance staff that is perhaps the finest component in the watch, it prevents it from breaking. And so it's that assembly, I'd say the smallest jewel there is about the size of a full stop. They're tiny, and so you can really appreciate just the amount of precision that goes in to make these. Right, so this is my workshop, and you won't find any silicon or silicium or any exotic materials such as that there, although I do use titanium. But in this room, I have most of the machines I need to make a watch. I have in the corner here a jig bore machine. It's like a vertical milling machine, so I can work on the X and Y axis, and I can rotate the table. And of course, I have a Z axis as well, where I can put either a scope to center the piece I'm working on. And once I have it all set up, I can replace it with a machine head. So I can drill or mill or whatever. It's a very, very useful tool. I have various lathes, from the large tool lathes in the corner to the very small watchmaker lathes, and any engineers would be fascinated with these because they're really very small. Some of them are even driven by a bow or a cable that you hand drive, and you can cut the piece you're working on with the other. It takes quite a bit of coordination to be able to do that. You can see just various other views of our workshop. This is my my own bench, and it's got the microscope beside as well, because we don't commonly use it. It's more for checking stuff rather than working all day under it. We use the eyeglass. And there's my lathe with, here we have an indexing fitting. And by using that, there's a worm gear here on the bottom, and you can advance the machine head by very precise degrees. And we use this principally for cutting wheels. So you would have another machine head mounted on the cross slide. You would index it with the wheel, cut a tooth, bring it back, advance it to the next wheel, and so on. And you can, those discs are interchangeable, so you can have a vast variety of tooth counts based on that. And that's the small watchmaking lathe. And again, another view of the jig bore. Just some lathe work. And here you can mount, you can hold delicate components by gluing them onto a face plate. And in the past, they would use shellac. And you can work on, you can spin the bridge and work on putting a final finish on a bearing, or opening out a hole to take a jewel, or doing a milling. And here I'm machining a winding stem. So I'm cutting the square of the winding stem. I'm cutting the next diameters, and there it's close to finishing. And on this lathe, I'm doing the threading. So I have these are tungsten carbide discs rather than the old-fashioned dies. So I can actually turn something in hard metal, and with the tungsten carbide discs, do my thread. They're discs, so they roll, they don't tear the material. You get a very, very fine thread, and all I have to do after that is polish it. It's just good use of the modern materials that we have at our disposal. Other things we can do in the lathe, we can get complex shapes and say work on the arms of a tourbillon cage. And it just, once you have the arm, which is tapered and curved, once you have that machined, you can go on to the next stage, which is the polishing of the arms and the rest of the cage with great ease. You've got a uniformity by machining it accurately first, and then you can move on to the polish, and you can get a very, very nice finish by using this process. Other machines we have in our workshop, this is an example of a tool called a Jaco tool. It's for polishing pivots, or burnishing pivots more accurately. So with a bow, we would rotate the piece. You can see that it's going to pivot between this fitting, and there's a bed where the pivot lies, and you have different sizes depending on the diameter of the pivot. And with the bow, we will rotate this spool, which with little arms that we engage in the teeth, or rather in the arms of the wheel to rotate it. And I think we have a video here just to show it. So just put a bit of oil on the various surfaces. And it's notoriously hard to film these things and keep your hands out of the way as well. So I'm just fitting everything in place and locking it down. This is slower than I thought it would be. And there's the burnisher. So I just have to, you really have to get your hand in to feel the pivot under your burnisher. And once you have it, you have to be as straight as possible. Otherwise you'll get a very bad shoulder on the pivot. And so I'm rotating it and using quite a bit of pressure on the pivot while rotating it. And in French, to this day, the roule de pivot. They roll the pivots. It's not, you don't polish them. You're compressing the material, thereby hardening it, and you're getting a fine polish at the same time. Okay, so you can see the pivot there at the end. It's from a different wheel, and this is the assembly of a wheel. So just popping it together, put the wheel on top, and you can see there's a countersink which we rivet over the wheel to make sure it's solidly seated and it's not going to move. And there is a pivot that's has a nicely polished seat. Okay. I mentioned diamond tools earlier on. This is a diamond graver that's doing a diamond cut on a balance wheel, and when your diamond cut is finished, you don't have to do anything else. The polish is really, really high, and it's amazing that a cutter can give you that finish straight away. And here we've just various other things. This is working on a case. And really what I'm trying to show is just I'm trying to give a
You wanna start?
representation of the type of tasks I go through the various machines.
That's not your way there, is it?
No. And this is the jig bore machine. So I can clamp things onto the table, center them very, very precisely, and there I'm using the tungsten carbide mill end to drill into a case. For prototyping components, it's invaluable. You can it's much slower than making things in production. But if you're working on a prototype piece, it's good to see how something is going to work by making it by hand first, and then when you're certain that it works, you can alter the CAD drawing to make sure that you've taken all of the modifications into account, and then you send it off and you get it made by CNC, and you get them made in quantities. Here we have a bridge that we're centering over another to make sure that it's utterly centered. And so you'd mount everything and then drill right through the hole, and then you're certain that the jewel that you set into the bridge is perfectly centered over the main plate. And more machining. Again, we can rotate the movement on the side and drill for the winding stem. So you can see just through all of these tools, like there's a wide variation of what you can do. There's with the tools, and bit by bit you can work out how to make every component in the watch by using the lathe, the jig bore, and your hands. So still, for prototyping or one-off pieces, you would cut out a piece of steel in the old-fashioned way with a fret saw. Then you file it to shape, and you might machine it on back into jig bore again. So you'd machine for screw holes, for pinholes. If there's a very precise function, you'd use the jig bore machine to hit those parts that are critical. Steel components, once they're made to size, we have to go through a hardening process. So there's a component underneath that flame. Once it reaches a cherry red color, we drop it into oil or water, and then we clean it up and blue it to bring it to the correct temper. If we left it fully hardened, it would be too brittle, it would break. And so that's how we achieve the right hardness for our components. We use an awful lot of jigs to hold the fine components, so as you can do fine finishing, such as beveling, or even just cleaning up the parts. And it takes a bit of time to make jigs for every single component, but it's well worth it. It's the only way you can work to high quality. And so, for instance, this is a jig I'm making for a restoration piece. So I'm just turning the disc. It's a tourbillon cage for a pocket watch. And then I cut out the bits that are in my way. And now I've clear access to work on the curved part of the bridge with files and polishers. And you can see it's going through the polishing stage there. And there's the finished cage. And there it is, assembled. We also do an awful lot of hand polishing. One thing at this level of watchmaking that's of critical importance is finishing. It's as important as the function. These are expensive watches, so they can't just work well. They have to look beautiful as well. And a lot of the skill in making these watches is in high finishing. So this is a tin block with diamond paste on it. I've mounted a part onto a jig, and we rotate it on the tin block until it starts to grind the component. And the result is, you can see I have a mixture of finishes here. I have curved arms, which I've protected, but the top part there is mirror finished, and it's literally a mirror. I mean, you can, I don't have a picture here, but you can see a reflection of your tweezers in the steel once it's properly polished. And there's the finished article with the curved arms, with the varnish taken off. And there it is, finished and fitted to the watch, and the finished watch. We do various other finishes, such as here I'm doing spotting or perlage, where you use an abrasive to swirly circles all the way around. You don't want to see any surface where there are any machine marks visible, so we do something to every surface. In industrial watches, or more mid-range watches, we would use sandblasting or industrial processes to give an overall finish. But at this level, you want to handwork every surface, and a large part of the artistry is in the finishing. Here I'm beveling. I'm using a piece of wood with some diamond paper, another modern material, to put there's a 45-degree angle on the surface of every spring, every lever, in this case, a bridge. And I'll get it to a high state of finish with the diamond paper. You go through different grades until you get it very highly polished, and then you'd finish with natural materials such as wood impregnated with diamond paste, and that's a bit of elder pith wood. It sounds quaint, but you won't get a better finish with anything else. If there was a modern material I could use to replace it, I would, but it just works so well. And here is, you have circling based on a jig that I mounted plates, and I can circle it very precisely in the lathe. Then it goes through an electroplating process for either gold plating or rhodium plating. And there's the finished bridge in the watch. This is the same piece. It's you have the teeth of a wheel. You can see how rough they are. It can be like that after finishing or after machining. We go through each tooth and finish them. That's the same wheel, and you can see the reflection of the tooth on that face there. It's a mirror finish, and that's reducing your friction. So every effort in that to that end is worth it. That isn't actually decorative, that's functional. And that's the top wheel. And there it is in the watch again. And that's the rest of the watch. Okay. I've just a few more slides on, here we have hands that I'd finish them again on a jig I'd make up. The jigs, they're not works of art, but they're not meant to be. They are just to supply a function, which is to hold something accurately, while you can just worry about finishing it without worrying about breaking it. And there's the set of hands fully polished. And then I heat treat them to get the blue finish. And you can see the center of the minute hand. I polish that on a 10 block again. So there's a lot of finishing just in a set of hands if you're going to do it properly. Here we have the balance wheel. We poise it to get the weight perfectly even. If you don't do that, the timekeeping is is completely out. So we, to get as precise a timekeeping as possible, we try and poise that as perfectly as we can, first on this poising tool, and then later on when it's in the watch, you measure the timekeeping, and by analyzing the rates in different positions, you can determine where the rest of the overweight is and remove it at that point. Here we're making a hairspring based on the overcoil shapes that have been worked out by great watchmakers long time ago. And this is a hairspring or vibrating tool. You have a master hairspring underneath. This spring you're working on, you're trying to determine the length of the hairspring to match the two frequencies of the top balance and the one below. And here you can see they're actually quite close. You can see that the arms are moving more or less the same together. And for anyone who's done it, it's the first one you do, you'll spend a few days doing it. It's and you'll probably go through a few hairsprings, but the more you do them, like anything, the easier it gets. And there's the finished hairspring. And this is the HB1. This is the back of it. You can see all of the components are finished and adjusted, and the watch is all together. So you can see there's a high level of finish there, and hopefully you'd have seen in the previous slides how I work towards that. And there's the front of it. So the HB1 is it's a chronograph with triple calendar and moon phase. It's based on an existing caliber, Valjoux 88, which is a venerable old caliber that was used by a lot of the very famous watch houses in Switzerland. I had the good fortune to come across a stock of unused 88s, and what I do is I take them completely down to component form, refinish the components I'm going to continue to use. I design and remake other components, and it's housed in this titanium case with the sapphire dial. So that's pretty much what I do. Just to move on, sorry, I think I'm running over time here. But I just want to talk about two things. First of all is the concept of an Irish watchmaking industry. Why wouldn't we do that? The idea of a watch, a high-end watch having to come from Switzerland, that day is long past. You've got watches made in England and Holland, Finland, Germany. They don't have to fight this perception of not being Swiss anymore. They're equally regarded as the highest of Swiss watches are. And in fact, I think we have broken through the glass ceiling by making some very expensive watches here in Ireland, and we have a ready market throughout the world. We don't make them in great numbers, but at the same time, I think we've addressed the perception that a high-end watch can't be made here in Ireland. We've shown that it can, but we're very small, and I think more could be done. But the biggest thing standing in our way of actually achieving this is the lack of watchmaker training in Ireland. The day we lost the Irish Institute of Horology was a very bad day for watchmaking in this country, but I think for this, we lost something in this country as well. We lost a great expertise. There was wonderful pride in what was done there because it was world-class. And even though in the midst of the 80s, in the middle of the 80s, when I graduated from the Irish Institute of Horology, anybody who chose to stay in Ireland and work got work. That was against a backdrop of almost 20% unemployment in Ireland. And they didn't all get work as watchmakers, but surely that doesn't matter, because I think a lot of people go to university and they get degrees in any given domain, they don't necessarily work in that domain once they leave. I think the metric we should use for the success of any kind of educational institution is how many jobs are, how many people get jobs out of it. And the skills that a watchmaker learns, they're transferable across so many different industries. A lot of the students who graduate from the college, they were snapped up by Intel, by biomedical device industries, by other precision industries. Anything that required prototyping or even managing a line where precision was of paramount importance, use these people. And I think that's one aspect. The other aspect is we could actually have a watchmaking industry. So I think if there is anybody who is in this room or listening online who can do anything to actually move us to a situation where we re-establish watchmaking in Ireland, or watchmaker training in Ireland again, if you could make any effort, it would be all for the good. I think we could regain something very valuable that we lost. So with that, would anyone like to ask any questions? Oh.
Just welcome to questions from the floor this evening, but we might start with some questions online just to get the juices going, and I'm sure there are people here who have some questions they'd like to ask. So what I would ask is, if people who are in the room, if you want to ask a question, please be mindful that there are attendees online. So I will hand you the microphone, or my colleague John will hand you the microphone. So just wait till you have the microphone in hand before you ask the question. Any questions online, John? I do, yeah. And just to say, there are a good few questions online, so if we don't get to everyone's question, we will endeavor to answer them and send you an answer by email. And to start off, I know we've got a couple of secondary school students in today. One of the questions online is there a book that you recommend for a beginner watchmaker looking for the historical and technical account of the trade?
George Daniels, who's no longer with us, he wrote this book, Watchmaking. And whenever anyone went up and asked him, Mr. Daniels, how do I do this or how do I do that? He'd just say, did you read my book? Because it's in it. And it really is the definitive book on how to make a watch. But it mightn't be immediately for someone who isn't a watchmaker, who could be difficult to understand some of the explanations, because when you haven't seen a lathe, it can be difficult to imagine how it works by reading text and looking at a drawing. But there's a vast amount of information online. There are YouTube videos. There's a lot of channels that are actually really educating about watchmaking now. But if you're looking for a book, Watchmaking by George Daniels.
Thank you. And another question I have is, like in the construction industry, there are architects and engineers, and is that the same in the watchmaking industry, or do people usually do everything?
No, it is the same as in the construction industry of constructors and the watchmaking industry. And many of them would have watch design experience or watchmaking experience. They increasingly, the best courses that are for watchmaking would teach both, and then people would branch out and specialize in one area or another. But the best there are courses that only do construction. But from my experience, the best constructors know how to make a watch as well, because they can understand what a watchmaker is experiencing, what's difficult to put together, and what's more likely to work. Some things that work on a computer screen don't necessarily work in reality. So I think that interchange is very important.
We take a question before
Yeah.
Hello. You mentioned that you use for your the Value watch. How much of that watch is actually, what percentage of it is yours?
Oh, in components, in the number of components, it's not very high. But every single component is reworked. So there isn't anything put back in the watch without having been polished or reburnished or beveled or reprofiled. But there isn't an awful lot of movement components that are mine. There are a certain number. Obviously, the case style hands, they're all mine.
I suppose a comment I have is for someone starting in the watchmaking business that playing around with clocks is not a bad way to get there.
Absolutely. There are even, you can buy, some people have bought pocket watches as well, either watches that weren't with their cases anymore. But definitely clocks are, it's an easy first step.
Yes.
Yeah.
Because
I would caution though, don't take anything apart that has any great value.
And I'll take one from online, and then for the jewels for the bearings, question, are they porous so they can retain the oil, or is it another?
That's a good question. It's no, they're not. They've got good surface tension, and with the previously and even currently, you can still have bearings either in brass or in copper beryllium, and you tend to have the lubricant migrating from the spot where you want to keep it. But with jewel material, both by the shape of the jewel, because it's got a countersink to retain oil, but all around you've got a fairly strong meniscus that is retaining the oil in place. So yeah, no, it's as unporous as possible.
I've got one here quickly. Lots of these start with excellent presentation, by the way. I'm skipping them all for value. What accuracy would you be able to achieve in the watches that you make? The person says seconds per day.
I try and get the time. I get the timekeeping between. Okay, I should explain that watches are affected by gravity. The timekeeping is affected by gravity. So in each position, particularly the vertical positions, you get a different rate of time. And a lot of what we do is to try and get those times as tight or as close together as possible. If you get under 10-second variation is considered to be good, acceptable. But you would then set the average time, so it would be between 0 and 5-second gain a day. And you don't know how the watch is going to be worn, what temperatures it's going to be exposed to, or anything like that. But if it's outside the 0 to 5 seconds a day, you know, justifiably our clients might like to get it closer than that.
Another question here in the room. It's not very pretty.
Thank you.
You mentioned earlier on, I've got two questions for you. You mentioned earlier on the use of complementary metals to combat thermal expansion issues.
Yes.
And is that still a technique used today, or is it solved through other materials science? And for your hand machined parts that have maybe like critical dimensions for functionality, do you have some sort of like dimension verification process that you do and tools you use for that? Yeah, just what does that look like? I be used to it in an automated metrology department, but by hand how you do it, I can't actually picture how you do it, something so small and fine.
Yeah. First of all, with the metals, we don't use thermal compensation very often anymore. It's very, very rare. You had, I think he was a metallurgist called Guillaume. at the turn of the 20th century, he came up with these ultra stable materials, Elinvar and Invar. And one is for the spring material, and the other is for the bounce. And they're extremely thermally stable. And in fact, it was the only Nobel Prize ever won in watchmaking. So there's a metallurgist, not a watchmaker, who won it. And so, yeah, the stability of materials has increased to the point that we don't use thermocompensated materials anymore. Often there are some people who still do, and some of them using very, very exotic materials. The other thing is, I mentioned silicon and silicium, and they are affected by temperature, but they use plated surfaces. They plate these with other materials to actually make them thermally stable. And that, in addition to the anti-magnetic properties of silicium, means that you get really unheard of precision for a watch. As to the other question, what we would generally do, like if we're, it's very, very important. You design a theoretically perfect component, and but when you're machining it, you're never going to achieve that perfection. You always have to work within acceptable tolerances. And we would use, I don't have a photograph of it here, but you would put the component on a lit surface. It would be backlit generally, and that's magnified and projected onto a glass table, and you would put a drawing on that. It's a retroprojector. And so you can line holes up, you can line teeth up, you can have the profile of a spring or lever, and you can see with great precision what how close you are or to the precision. Yeah, exactly. And now with CAD, this is another innovation with CAD. You have tools, very sophisticated laser and optical tools that it's amazing to watch. You put a tray of parts underneath this, and it will go around and measure the significant parts and compare it against the CAD drawing. So it's getting easier and easier in some respects. Now, I don't have that, but like, yeah, great questions.
I'll just take one more one from online. This is asking, in the absence of the Irish Horological Institute that closed, what would you say the best route for an aspiring watchmaker in Ireland?
There are two very good schools in the UK. There's one in Manchester and one in Birmingham, and I've directed some people who are interested to go there. So there are a few Irish who have gone through those. There's an organization called WOSTEP. It was it's a watchmaking school in Switzerland. I went to it, and it was geared towards non-Swiss watchmakers, and they have set up a network of watchmaking schools around the world, and just not here, unfortunately, not yet. But that could be one route if we ever did get watchmaking up and running again, to engage with one of the organizations such as WOSTEP to try and use their template of education to reestablish a watchmaking school. But that's no good for someone who's making that inquiry. Manchester or Birmingham, I'd recommend, or contact WOSTEP in Switzerland.
We have time for one final question. Anybody want to join one question?
I was just meaning to ask you, at what age did you find out that this is exactly what you wanted to do, to make watches?
Very good question. It's great to see yourselves there. Like, you're obviously still in school and you're thinking about what you want to do. I was, I suppose, about 17 when the idea was suggested to me. My father he repaired clocks, and he did it on the side. He was a compositor. He worked with a typesetter in the newspapers, and so it wasn't his profession. It was just something he did on the side. So we always had clocks in the house, and it might say, well, why did it take you so long to discover you wanted to become a watchmaker if I just grew up with clocks? But I was interested in mechanics, and I just didn't see this applying to me. My father suggested it, and once the thought got into my head, I was like, yeah, that sounds good. And I'm almost from day one, once I started in the college, I was like, okay, I love this. This is for me.
So you knew you wanted to do it when you went into college?
Yeah, definitely, yeah. And actually, the funny thing is, my father didn't want me to become a watchmaker. He said, listen, go to that college and you can get a really good job in Aer Lingus as an instrumentation technician, because he understood straight away that these skills were transferable. And so when I came back and said, oh, this is fantastic, I think I know what I want to do for the rest of my life, I want to be a watchmaker, he's like, that's a terrible idea. You know, in the 1980s, you only had quartz watches. And I wanted to work on mechanical watches. It looked like a complete dead end. But I don't think anyone could have foreseen how the watchmaking industry transformed.
Thank you. Thanks.
You're welcome.
Fortunately, that's all we have time for this evening. I'll take a few minutes just to obviously thank John for an outstanding presentation this evening. So please, everybody, put your hands up.